Sometimes we come across a polynomial that we just can't factor. Recall that we have the concept of a prime number. A number is prime if it's an integer whose only factors are itself and 1, plus or minus. So the concept here is that a prime number can't be factored in any interesting way. A prime polynomial is an analogous concept. A polynomial is prime if it can't be written as a product of polynomials that have integer coefficients, that are of lower degree, or that have smaller coefficients. We can always factor out a plus or minus 1. A polynomial is prime if we can't factor out anything else. How can we recognize a prime polynomial? Assuming no common factors, the following polynomials are always prime. Anything linear is prime. So if we've got something linear, we don't need to try to factor. A quadratic, so degree 2, with 4 terms for which grouping fails. So if we have a quadratic polynomial with 4 terms, we try factoring by grouping. If that doesn't work, then it's prime. A quadratic trinomial, so 3 terms, degree 2, for which the AC method fails. If we have a quadratic trinomial, we try the AC method to split up the middle term. If that doesn't work, then it's prime. So let's see some examples of that. So here I have a quadratic with 1, 2, 3, 4 terms. To factor it, I'm going to try grouping. So I'm going to set up a rectangle here. I'll have an x squared minus 4xy plus 3x minus 12y. Greatest common factor in my first row is x. So in my first column, I'll need another x, because x times x is x squared. In my second column, I'll need a negative 4y. X times negative 4y is negative 4xy. In my second row, I'll need a positive 3. X times 3 is 3x. And then 3 times negative 4y is negative 12y. So grouping was successful. I can factor this as x plus 3 times x minus 4y. And so this is not prime. Okay, next example. This is a quadratic trinomial, right? 1, 2, 3 terms. So I'm going to try to use the AC method. AC is 5, 1 times 5. B is negative 4. Well, 5 I can only factor one way, right? Negative 1 times negative 5 is 5. But negative 1 plus negative 5 is negative 6, which is not negative 4. So what I've seen here is the AC method fails. There's no other way I can factor 5 as a product of two negatives. This is prime. What about 2x squared minus 7x plus 6? I'll try the AC method again. 1, 2, 3 terms again. AC is 2 times 6 is 12. And our B is negative 7. Oh, negative 3 plus negative 4 is negative 7. And those multiply to positive 12. I can split up that middle term. So I think the AC method is going to succeed here. Let's see, drawing out our rectangle. Our first term is 2x squared. Our last term is 6. We've got a negative 3x, a negative 4x. First row, my greatest common factor is just an x. First column, I'll need a 2x. Second column, I'll need a negative 3. Second row, I'll need a negative 2. Negative 2 times negative 3 really is positive 6. So my original polynomial factors as 2x minus 3 times x minus 2, and it is not prime. Okay, last one. We've got 1, 2, 3, 4 terms. So we're going to try to factor by grouping again. Let's see, I've got an xy, a negative 5x, a negative 3y, and a plus 7. I feel like this isn't going to work out, but let's see. First row, I have a common factor of x. That's great. First column, I need a y. Second column, I need a negative 5. Second row, I need a negative 3. Oh, but negative 3 times negative 5 does not equal positive 7. So grouping fails. This is prime. So for quadratics anyway, if the methods that we have for factoring them don't work, that means that we're faced with a prime polynomial. It means we can't factor it at all. For higher degree, maybe not, but as long as they're quadratic, if we can't factor by the methods we have, it's prime.